Look at how far we've come. This little board costs about $1 or $2, and it can be accessed and made to do stuff from anywhere on the planet. Unreal. Welcome to the tutorial on IoT or Internet of Things. If you're looking to get started on IoT but don't quite know how, don't worry, you're not alone. It is very easy to get confused by the huge number of devices and platforms available nowadays. The simplest way to get started with IoT is to, well, buy an IoT-enabled device like a smart bulb, just like the one I reviewed about a year ago, which is, by the way, highly recommended. It would come with a custom app which you can use to control it from anywhere on the planet with the help of the internet. Now, if you want to get a little experimental and would like to add IoT capabilities to your thermostat, your fan, your coffee maker, basically anything that plugs into an electrical outlet, you could grab one of these Sonoff switches for like $5 and plug it into the input of any device in your home and then control it with an app over the internet. The Sonoff switch is also a very good way to automate things around your house. You can check out the tutorials that I did on the Sonoff in the description below. But today we're diving a little deeper into DIY IoT. We are creating our own IoT setup that could be used to basically do anything. You want to turn on an LED or drive a robot or start or stop your coffee maker. You can do all that over the internet with this little board. Now this board is the Wemos D1 Mini. It uses this ESP8266 chip, which is made by Espressif. The chip is mounted on a Wemos D1 Mini board, and this whole board here has a built-in USB connector, so you can easily program or read write to the chip. So what we're going to do is, first of all, connect this Wemos thing to our computer and then use the Arduino environment. That's right, there is no need for any additional software or additional hardware. This is not a shield that goes onto an existing Arduino. No, this is a standalone microprocessor that can be programmed using the Arduino environment. So let's go ahead first, open the Arduino Ide, and you guys should know the basics of Arduino by now. We've done a lot of stuff on Arduinos on this channel. If you don't, you can check out the tutorial in the description below. So once the IDE is open, we go to preferences, and you can just copy and paste this JSON link that I got from GitHub Wemos Arduino. And after this, we go to Tools, Boards Manager, and install the ESP8266 by ESP8266 community. Now, by default in Tools, Boards, your board should be an Arduino by default because, you know, that's what you use the IDE to program. But if you come down here, we have just installed a bunch of different boards, and we will take the Wemos from here. The hard part is basically over. Now let's run a code on this board. Now if you go to File Examples, we also have added a whole lot of examples here. So let's go to ESP8266, and obviously let's do the Blynk program first. We see that the program just blinks the built-in LED for a delay of 1 second, so there's nothing complicated here. Just go ahead and run it. And just like that, we are talking to the Wemos. We have successfully run our first program on the Wemos D1. But hey, you say, what's the big deal? We're still only communicating through this cable and then just uploading the code on the processor on the chip. We didn't do anything over Wi-Fi. We didn't, do any cool stuff, any IoT stuff. So, okay, I hear you. Let's go ahead and control some stuff over Wi-Fi. Let's connect this LED to pin D1 on the board, and we have a problem here. How are we gonna control the LED over the internet? See, to control the board over Wi-Fi, we need a sort of an application, a kind of a button which is connected to Wi-Fi, and will transmit a signal when we press that button to help this board do something. Luckily, our phones are already connected to Wi-Fi, and there is no need to write an app or create a web server like people used to do in the past, because some MIT guys developed this cool app called Blynk, and it is so damn easy you wouldn't believe it. Just download the app, create new project, select your device from here. So we're gonna take the Wemos D1 mini, and that's basically it. We're up and running. Just swipe left and add some sort of a button, and select which pin you will be using. Since we're using the D1 pin for our LED, we're going to select D1. So here it is. We have the button, and that should control the app. So in our Arduino environment here, we have to obviously download the Blynk library as well, because we are using the Blynk app. Some of you might have it pre-installed. That's great. If you don't, you can just download it from the GitHub page and copy and paste it in your libraries folder. Once you have it, you can just go to examples, and what do we do? We do Blynk. Now in this sketch, it's pretty simple. We only need to change the authentication code, which Blynk should send to you as soon as you log into the app on your phone. So this is my authentication code, and I'm going to just paste it here, and that's really about it. We're ready to run the app. So what we're going to do is run it on our computer and then flash it on our Wemos. And after that, we're just going to go to the app here and tap the play button. That should run your project. And once the project is running, you can basically use a button to switch the LED on and off. Congratulations, we have just controlled an LED over the internet. Now you can just play around with the Blynk app and build all sorts of crazy stuff from here on. If this was helpful, please give this video a thumbs up and check out my other projects on the channel. Keep fungineering and stay safe.